Hello everyone. Earlier we have seen the first part of requirement and specification chapter. In that we saw the requirement engineering process. Today we will be seeing some more concepts that we will be learning in the requirement and specification. So after the in the requirement engineering process, after the it has followed a particular phases. The main phase is validating. Once the requirement is collected, it needs to be validated. So here it is one of the very critical engineering process of the software, critical engineering software process. So how these requirements are validated? So they are based mainly checked for the validity, consistency, completeness, realism, and verifiability. So let us see what are these things. Okay, so the first one, that is the validity check. So here when we say about the validity check, a user may assume only certain types of functions that software system has to perform. Only the working process he is going to imagine, and he is going to validate it, how they are going to be executed. So here the additional function may require the same system when further analysis and critical thinking is performed in the validity checks. The second type is the consistency checks. So here the conflicting requirements lead to inconsistency in a software system to be developed. So that's why this consistency check needs to be executed. This happens due to different descriptions, the system functions and disagreeing constraints. So the consistency checks must be executed because of the say differences between the system, the functionalities. Okay. The third one is the completeness checks. Here in this completeness checks, the functions constraints that are imposed on the software system has to be developed. Okay. So here we need to make sure that whatever the requirement is done, it must necessarily to be completed. Any ignorance by thinking any capability to be imparted on the system is simply silly, or simply it needs to be understood. Okay, so it should be simple. The functionalities needs to be executed correctly here. So we need to go for the completeness checks. How that completeness checks need to be executed. Next one is the realism check. So here realism means the whatever the real aspects, okay, whatever the existing technology is there, based on that one we are if we are designing a new system. So here we need to compare the what the process of the existing system. Okay, so we need to check whether it will work with the existing system or not. So that realism means working model. Okay, we need to think of the working model and we need to go for the realism check. Next is the verifiability check. So this verifiability check should emphasize that the software system be developed and must meet the requirements. Okay, so we need to, when we are creating the requirement itself, we need to verify them whether it is going to execute or not. So here the requirement specification are verifiable and would minimize possible quarrel between the customers. Okay, so whatever the requirement is being collected, we need to go through that one. So this is how the requirement validation is executed based on the validity checks, consistency checks, completeness checks, realism checks, and verifiability checks. Okay, so to execute this requirements or specify them, we need to go for different models. So we'll see one of the models here, that is the object model. Okay, so I hope you know what is this object, the term object in the IT field or the computer science field. Okay, when we refer to objects or classes that we have already learned in C++ and Java. So here objects refer to the real world entities. Okay, so the system must be executed based on the object. The requirement may say made, the requirement be collected, and they must be divided into objects and the classes. Okay, so what is this object? As the definition says, it is an abstraction over a set of an object class is an abstraction or a set of object with common attributes and the services provided by each object. Okay, so this, when we talk about the object, as we already learned in some other subjects. Okay, so we need to execute them, we need to go for the classes, we need to, for the abstraction. So based on this one, various models may be produced. Based on the object models, sub models may be produced. In that one, the first is inheritance model. So we have learned this term. Inheritance means we are going to say take the process or the operations of the parent class to the subclass. We have learned this in C++ and Java. Okay, in the inheritance, a subclass will inherit the properties of the parent class. Okay, the same applies here. So their object is divided into classes. Okay, so here the subclasses will inherit the properties of the superclass. Okay, so different types of inheritance have been defined. So all will work here in the for the requirement collection. Okay, the second one is the aggregation models. Okay, so here in the aggregation model, when we think about the object for the requirement collection, there will not be a single object, there will be multiple objects that will be working together. So they will be working on a particular system only, multiple objects. Okay, so that can be specified using the aggregation model. Okay, so third one is the interaction model. As I already told, multiple objects will be there, so they will be working together for executing for a common system. So the requirements may be executed in such a way that the multiple objects have to be created and they need to work together. So that is what happens in the interaction model. So here the object model or the object class identification is recognized as a difficult process, as it requires a deep understanding of the application domain, because we should know the complete system, the complete application, which are the different objects, okay, of that application. So then only we can create the requirements of a complete system. Okay, and these object classes reflect domain entities and are reusable across different systems. Okay, so this is how an object model can be used for the requirement and specification. So we will see the second type of model, that is data flow model. It is a very important model, the data flow model. So here these data flow are nothing but it is an initiative, okay, or we are going to show in the requirement in a document, we are going to show how the process is going to happen, how the system is going to be executed based on the data, how the data is going to flow in a system. So that we need to maintain. So we need to make some say designs, we need to represent the process of a system. So so this can be achieved by going through different systems. So here for the how can these process can be shown using a diagrammatic representation. So here we are going to use different notations. Okay, so for functional processing we are going to use rounded rectangles. For storing the data storage we are going to use rectangles. And how the data movement will happen, for that we are going to show the labeled arrows. Okay, so this object model is a traditional visual representation of the the data flow model is a traditional visual representation of the information flows within a system. Okay, so a neat and clear DFD can depict the right amount of the system requirement graphically. Already I have told you that the requirement will be completely in documents. So when I say object model, data flow model, these are also in documents only. The thing is, we are going to represent them in a graphical manner. In object models, we are going to go for either the inheritance or the aggregation or the interaction models. Whereas in DFDs, we are going to use notations for the flow of data. So the main objective of this data flow model is to show the scope and boundaries of a system as a whole. So a complete system can be defined using the data flow model. So these may be used as a communication tool between a system analyst and any person who plays a part in the order that act as a starting point or redesigning the system. Okay. So the many observations can be used about the DFDs. The main observation may be all names should be unique when we are designing a DFD for the systems. The objects or the functional processing, they should be unique. Okay, so as the people who are seeing those documents shouldn't get confused. Okay, so this DFD is not a flowchart. You must remember this. This will show the process, but it is not a flow chart. Okay, so here we are not going to show the logical decisions. Okay, so only we are going to show the flow. Okay, so we need to make sure that the DFD becomes shouldn't becomes very complicated. Okay, so we need to keep some say details in the mind when we are designing the DFDs. Okay, so this was the second part of say requirement and specification.